Hi, the Gauss-Seidel iteration method is very similar to the Jacobi iteration method. If you remember, in the Jacobi method, we would start out with our initial values, find new ones, and then the new values aren't used until the next iteration. The difference here is that in Gauss-Seidel, when you find a new value, it is immediately used even though that iteration is not complete. So because you do that right away, and because you are continuously using the most recent update of each variable, it reduces the number of iterations. So this is the same problem that we did in the Jacobi method, and you still start out the same way. You reorder the equations to try to meet the convergence criterion as best as you can. But notice here in iteration number 1, we still started out with initial values, but when new R was calculated and its percent relative error was calculated, R was assigned right away to be the new value of R. So the newest value of R is then used in the calculation for S and T. Same thing with S. When a new value is found for S, it is immediately used to calculate the new value of T. Rather than waiting until iteration number 2 to introduce the new values of each variable, in Gauss-Seidel, you immediately use each new value of each variable. In the Jacobi method, we had 24 iterations, I believe. In this method, it took us 10 iterations to get below 1% error. Okay, so that is the basic difference. Now, the only other thing I should mention is after iteration number 1, you start with initial values, but in iteration number 2, you already have the most recent updated values for each variable continuously being updated throughout each iteration. So this is the portion right here that you can now copy paste over and over and over until you reach your percent relative criteria requirement. All right? And then as before, you can still check your work with MathCad using the solver block tool, or you can use the reduced row echelon function. But you see, we're getting the same results as when we did this problem using the Jacobi method. I will point out, you'll notice that the percent relative errors start out with 100% again, and they jump around quite a bit. See, there's 166%. But as you progress, you'll see that they start to settle down. And you'll see that this settles down much quicker than the Jacobi method, which makes sense because you're always using the most recent value of each variable rather than waiting until the next iteration. Okay, so I hope this helps you work these problems.